everyone, we're going to sketch the curve and find the area that it encloses. So this is going to be a limicon. R equals 3 plus 2 cosine of theta. Since 3 is greater than 2, it's going to be without an inner loop. I'm assuming, which I shouldn't do, but I am, that since you're trying to find the area, that you're more familiar with polar curves. So I went ahead and set this up, and we can go ahead and start graphing this. We'll start at 0, we're at 5. So 1, 2, 3, 4, 5. At pi divided by 6, we're close to 5. 1, 2, 3, 4, 5. At pi divided by 3, we're at 4. 2, 3, 4. At pi divided by 2, we're at 3. 1, 2, 3. At 2 pi divided by 3, we're at 2. And at 5 pi divided by 6, we're a little less than 2. And at pi, we're at 1. So basically, here is your graph on the upper portion. Since it's cosine, it's symmetric to the polar axis. So we can just copy down our values for pi divided by 6. For 11 pi divided by 6, that was 4.234. It's close to 5. And then at 5 pi divided by 3, we're at 4. 1, 2, 3, 4. At pi divided by 2, we're at 3. So you go 1, 2, 3. And then we're at 2. And then we're at 1 point close to 2. And then we're back here. So there's a sketch of the graph. You know, when it says sketch, it means you're not supposed to use a graph. But I had to use one here. So there's basically your curve. Now the goal of this is to see, we want to find the area that it encloses. So we're trying to find this area. Since it's in all 3 quadrants, or all 4 quadrants, sorry, we're going to integrate this from 0 to 2 pi. So all limicons usually will be integrated from 0 to 2 pi. If it's a circle, that can be a little different. But so let's go ahead and set up our integration for our area. So our area is going to equal the integral from 0 to 2 pi. That was basically what we were looking for. And then we just use our formula, 1/2 times r squared d theta. Now r is 3 plus 2 cosine of theta. All right, now let's go ahead and simplify this. Let's bring out the 1/2. So that's going to give me 1/2. The integral from 0 to 2 pi. Let's expand this. This is going to be 9 plus 12 cosine of theta plus 4 cosine squared of theta d theta. Now, to help integrate this, what I'm going to do is use an identity for this piece. So what I'm going to do is write this as 1/2, the integral from 0 to 2 pi, and copy down my 9 plus 12 cosine of theta. And then for this piece, I'm going to write plus 4 times 1/2 and expand this as 1/2 times 1 plus cosine of 2 theta. And that's just because it helps us integrate. Now the next step I'm going to do is I'm going to take 4 times 1/2, which is going to be 2, and then go ahead and distribute that and add it to 9. So when I add 2 to 9, that's going to give me 11. So let's do that and simplify all this. We're going to get the integral from 0 to 2 pi. Now we have 11 plus 12 cosine of theta, and then we multiplied through by 2 because we had that 4 times 1/2, so that's going to be 2 cosine of 2 theta. Then we do d theta. Now we can integrate this, so this is going to give us 1/2 times 11 theta plus 12 sine of theta plus 1/2 times 2 is just going to be 1. So this is going to be sine of 2 theta. You're just multiplying this by 1/2. Okay. And we're evaluating from 0 to 2 pi. All right. So let's do that. And we're going to get 1/2. And this is going to be 11 times 2 pi. And the rest of this is going to be 0 plus 0. And subtract, everything's going to be 0. So basically, this is going to end up being 1/2 of 22 pi, which equals 11 pi. So that is our area. Thank you. Have a nice day. Bye-bye.